Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's section, I'm going to discuss about oxidation number topic, students. Here in this section, I'm giving the best tricks for the oxidation number. Okay, now, and I'm going to discuss all the rules in the oxidation number, students. Okay, then you will get the clear idea on this topic, oxidation number. After this topic, students, you can easily calculate oxidation number of any element in the compound. Okay, now I'm going to discuss first of all what is oxidation number. Okay, so first definition, students. Oxidation number. What is oxidation number? Oxidation number means it is an apparent charge on an atom. Okay, it is an apparent charge. Oxidation number. Oxidation number. What is oxidation number, students? It is an apparent charge. Apparent charge on an atom. Okay, na? So that means on atom what is the charge is appeared, that is calling as oxidation number, students. And one more definition, students, see here what is the one more definition. It is defined as oxidation number is defined as a number, students, which indicates the loss or gain or sharing of electrons by an atom during the formation of a chemical compound. Now see, students, what is that one more definition? It indicates the which indicates the loss. That means here oxidation number is defined as a number. It is a just number, students. That means that number indicates the loss or gain. Okay, it is the number definition. It is the number which indicates the loss or gain or sharing of electrons by an atom. Sharing of electrons by an atom during the formation of a chemical compound. During the formation of a chemical compound, students. Formation of a chemical compound. Okay, so this is the definition. What is this meaning, students? It is the number which indicates the loss or gain or sharing of electrons by an atom during the formation of a chemical compound. For example, here it is an apparent charge. For example, Na plus I am taking here, Na plus. Okay, Na plus, it is having the charge plus. Yes, on an atom there is a charge, that charge is appeared on the atom. That is nothing but the charge is called oxidation number. Okay, now here you just remember, students, plus indicates lost. Okay, now plus indicates lost, minus indicates, students, gain. Okay, it minus indicates gain. Just remember this one. Lost plus indicates lost, minus indicates gain. Okay, now see, students, it is a number which indicates the loss or gain or sharing of electrons by an atom during the formation of a chemical compound. For example, I am taking chlorine, students, Cl minus chlorine. Its atomic number is 17. Nearest noble gas element is argon. So that's it is ready to gain one electron to get the stability of argon. Okay, now so that's why it is ready to gain one electron. Are you clear? So that's why chlorine atomic number is 7. Nearest noble gas element is argon, students, 18. So that's why chlorine is ready to gain one electron. Okay, ready to gain one electron to get the stability of argon. So by gain of one electron, it becomes Cl minus. Are you clear? So Cl minus. So who is giving this electron? It requires one electron. Okay, so that's why here chlorine is waiting, which is which is ready to lose one electron, with that element it is ready to combine. Are you clear? So chlorine requires one electron, okay, one electron to get the stability of argon. And one more, sodium I am taking, Nana. Sodium atomic number is 10. Nearest noble gas element is neon. Sodium atomic number is 11. Neon atomic number is 10. So that means sodium is ready to lose one electron to get the stability of neon. Are you clear? It is ready to lose. Okay. Chlorine, it requires one electron to get the stability of argon. Are you understanding it? To get the stability of argon, chlorine requires one electron, and sodium to get the stability of neon, it is ready to lose one electron. Are you clear? So that's why chlorine is ready to combine with sodium, students, because it requires one electron, which is ready to lose one electron. Sodium is ready to lose, so that's why Na, by loss of one electron, it becomes Na plus. Correct? It becomes Na plus. Clear? So that means Na plus indicates electron lost, Cl minus indicates one electron gained. So this Cl minus and Na plus both are forms a compound. Correct or not? It is a number which indicates the loss or gain. So here chlorine gains one electron, sodium lost one electron, okay, or sharing of electrons by an atom during the formation of a chemical compound. So that's why chlorine, to get the stability of argon, it requires one electron, so which is ready to give one electron, with that element it is ready to combine. So that means here Na plus and Cl minus both are combined, NaCl chemical compound is formed. Are you clear? Chemical compound is formed. Understanding, students? Why chemical compound is formed here? Because to get the stability. So here chlorine by gain of one electron, it is getting the Cl argon stability, and sodium by loss of one electron, it will get the neon stability. Are you clear? So that's why sodium, it is losing one electron, chlorine is ready to gain one electron, so forms the NaCl chemical compound. Clear, students? Now I'm going to discuss rules, students, how to find the oxidation number. Oxidation number can have positive, negative or zero value, students. Okay, Nama? It can have positive, negative, zero values. Clear? Okay, now it has positive, negative, zero values also, students. Okay, oxidation number. First, rule 1. So what is the rule 1? The sum of oxidation numbers of all the atoms in a molecule. What is the rule 1? Rule 1. The sum of the oxidation numbers of all the atoms, oxidation numbers of all the atoms in a molecule is equal to 0. In a molecule is equal to 0. Clear? This one is equal to 0. So now see, students, first rule is what? The sum of the oxidation numbers of all the atoms in a molecule is equal to 0. For example, I am taking KMnO4 compound. Okay, example, students, KMnO4. Okay, KMnO4. Now how to write it, this one? How to find the oxidation number, unknown element? So first, what is the rule? The sum of the oxidation numbers of all the atoms. Which atoms are there? Potassium, manganese, oxygen atoms are there. Okay, now in a molecule is equal to the 0, students. So that's why how to write it, this one? First of all, oxidation number of potassium. First we have to write it, oxidation number of potassium plus oxidation number of manganese plus oxidation number of oxygen. Clear? This one, oxygen, this sum should be equals to 0. Are you clear? Understanding? Oxidation number of potassium plus oxidation number of manganese plus oxidation number of oxygen oxygen should be equals to 0. Here potassium 1 atom is there, here also manganese 1 atom, but oxygen's 4 atoms are there. So that's why here you have to take 4 into oxidation number of oxygen you have to take, students. Are you clear? 4 atoms now, so that's why you have to take plus 4. Okay, this is the rule 1. Now we are going to discuss the rule 2. The oxidation number of, what is the rule 2? Rule 2. Oxidation number of an atom in its elementary form is always 0, students. What is the second rule? Oxidation number. Okay, O number means oxidation number, students. Shortcut I am writing. Oxidation number of an atom in its elementary form. Oxidation number of an atom in its elementary form is always 0. Is always 0, students. Is always 0. So that means what, students? Elementary forms means, for example, I am taking elementary forms of hydrogen. Okay, now hydrogen, oxygen, nitrogen. Example, students: hydrogen, oxygen, nitrogen, sulfur, phosphorus. These elements, elementary forms are elementary forms are hydrogen. What, students? Elementary forms are hydrogen elementary form, H2, O2, oxygen O2, nitrogen N2, sulfur S8, phosphorus P4. So these are all elementary forms, students. Are you clear? So in these forms, students, here their oxidation number is 0. Are you clear? So that means in the chemical reactions H2, O2, N2, only, that is molecules, in the molecular state, the elements are there. Or another example also you can take, copper, silver. Okay, na? Elementary forms copper, silver. Copper elementary form is copper only. Okay, copper. Silver elementary form is silver only. Clear? Silver only. So these are all elementary form, students. Are you clear? So these elements are as it is existing, but these elements are in this molecular state only, they are stable. Okay, now though that these molecular states we are calling as elementary forms. So in these elementary forms, okay, elementary forms of an atom, oxidation number is what, students? 0. So that means here hydrogen, oxygen, nitrogen, sulfur oxidation numbers, how much, students? Their oxidation numbers 0. Clear? Oxidation number is 0, students. So this is which rule, students? Rule 2 is completed. Next we are going to discuss the rule 3, Nana. What is the rule 3, students? Rule 3. Now see, Nana, rule 3. Rule 3. So what is the rule 3, students? Hydrogen is always, hydrogen oxidation number is maximum, students. It is showing +1, Nana. Okay, na? Oxidation number of hydrogen is always, hydrogen is +1. Clear this one? Hydrogen. So what is the rule 3? Oxidation number of hydrogen is always +1. Clear? Hydrogen is +1, students. But in the case of, there is an exception, students. What is the exception? What is exception? In case of metal hydrides. In case of metal hydrides, example we can take sodium hydride, NaH. It is a metal, it is hydrogen metal hydride. In case of metal hydrides, hydrogen oxidation number is how much, students? Hydrogen oxidation number is equal to -1. You have to remember this is an exceptional case. Okay, na? Hydrogen oxidation number is maximum +1, students, but exception is metal hydrides. In metal hydrides, hydrogen oxidation number is -1. Clear this one? Oxidation number is -1. This is the rule 3, students. Are you clear? Rule 3 completed. Okay, Namma? So now we are going, see, students, now rule 4. What is the rule 4? What is the rule 4, students? Fluorine oxidation number is always -1, Nana. Fluorine oxidation number of fluorine is equal to -1. It is fixed value. It is always equal to -1, students. Fluorine. So if you want any compound, students, fluorine element is there, that oxidation state is -1. You have to remember. Okay. So that is the rule for students. Okay. Just one example. Sodium fluoride. Suppose sodium fluoride example I am taking. Here fluorine element is oxidation state how much, students? -1. Sodium we have to find it. So that's why here sodium X I am taking. Fluorine oxidation number is -1 equal to 0. Are you understanding? So here sodium atom X. So we have to find the oxidation number of sodium, nana. So that's why here I am taking instead of sodium X, and fluorine oxidation number we know that -1. Then how much, students? X plus -1 is equal to 0 means X is equal to +1. That means sodium oxidation state is how much, nana? It is +1. Clear this one? So like this you have to find it. So fluorine oxidation number is how much, nana? It is equal to -1. Right. Fluorine oxidation number -1, then you can find in this compound sodium oxidation state also. Next, nana, rule 5. Next rule 5. So what is the rule 5, students? Oxygen is oxidation number is always -2, students. Rule 5. What is rule 5? Oxidation number of oxygen oxidation number is always -2, students. So maximum, students, it is showing -2. Okay now, but there are some exceptions, students. Are you clear? So oxygen is showing -2 nano oxidation number. There are some exceptions. Here one example I am going to calculate. Oxygen oxidation state is -2 na. I am taking one example na. So that is Na2O I am taking Na2O. So I want to find oxygen oxidation number is -2 kada. In this compound oxygen is showing -2. For example sodium. Sodium which group element na? It is a first year group element na. So first year group elements oxidation number is always +1. So two sodium atoms are there. 2 into I am going to find oxygen oxidation number, students. 2 into sodium atoms, 2 into oxidation number of sodium according to the first rule. So how to write? 2 sodium atoms, 2 into oxidation number of sodium plus 1 oxygen atom into oxidation number of oxygen. Clear? It should be equals to 0. Are you clear? Is equal to 0. Now 2 into oxidation number of sodium is +1 because it is a first year group element. Oxidation number is +1. Okay, the next coming rules I will discuss. This first year group, second year group, what is oxidation number I will discuss. Okay, now here oxidation number of oxygen I am going to calculate. That's why I am taking as X. Then 2 plus X is equal to 0. X is equal to -2. So oxygen oxidation number is how much, students? It is -2. Clear? But here there are some exceptions, students. Oxygen always it is not showing -2. In some cases, nana, it is showing the different oxidation states also. So in which cases oxygen is showing the different oxidation states? For example, peroxides, superoxides. Here exceptions, nana, exceptions. So what are the exceptions? Exceptions of oxygen oxidation numbers. Okay, now see, students, here first one is peroxides. So what is the formula peroxides? O2 -2. O2 -2. What is the oxidation number of oxygen in peroxides? Here 2 oxygen atoms are there. 2 into X. 2 oxygen atoms are there. I am going to calculate oxygen oxidation number. So that's why 2 into X is equal to how much? -2. 2X is equal to -2. X is equal to how much, nana? -2 by 2. Here you will get -1 oxidation number. That means oxygen oxidation number in peroxides how much? -1. Clear this one? So that is the peroxide, students. Are you clear? O2 -2. And next coming to the second one, nana, superoxides. Superoxide. So what is the formula of superoxide, students? Superoxide formula is O2. This is peroxide. Now coming to the superoxide. Superoxide's formula is O2 -1. Clear this one? Superoxide formula is O2 -1. Then how to find it? Oxidation number of oxygen. 2X is equal to -1. 2 oxygens is equal to charge. How much there? That charge you have to take equal to -1. Understanding? 2X is equal to -1. X is equal to -1 by 2. Clear this one? This is a superoxide oxidation number. In superoxides, oxygen oxidation number is -1/2 students. Clear? And the third exceptional case, Nana, third one is ozonides. The third one is ozonides. Now see students, third one, ozonides. Third exception. Third one is ozonides. Clear? O-Z-O-N-I-D-E-S. Ozonides. What is the formula? O3 - 1. Clear? So what is the oxygen oxidation number in case of ozonide, students? What is the oxidation number of oxygen? 3x is equal to -1 because 3 oxygens are there. X, I am going to calculate oxygen oxidation number. Here how much charge is there, that you have to take equal to -1. Then x is equal to -1/3. That means in case of ozonides, oxygen oxidation number is -1/3. Now fourth case, students, what is the fourth exception in case of oxy fluorides? Oxy fluorides. So in case of oxy fluoride, students, there are two types. One is O2F2, another one is OF2. This is dioxygen difluoride. Okay, this is oxygen difluoride. This is dioxygen difluoride. Are you understanding? Now I am going to calculate oxygen oxidation number in this case O2F2. How to find it, students? Here two oxygens are there, 2 into oxygen oxidation number I am going to calculate X. Two fluorines are there, 2 into fluorine oxidation number is always -1, correct? Already I told you in the third rule, fluorine oxidation number is always -1, correct? So that's directly I am taking 2 into -1. This is oxygen we are going to calculate. 2x plus 2 into -1. Then 2x minus 2 equal to 0. 2x is equal to +2. X is equal to +1. Okay. In case of OF2, oxygen oxidation number, how to find it? X plus, because only one oxygen atom, X plus 2 fluorines are there. 2 into fluorine oxidation number -1. X minus 2 equal to 0. X is equal to +2, students. So these are the exceptional cases, Nana. Here in these 4 cases, here if you observe, Nana, here in case of peroxides, oxygen oxidation number is -1. In case of superoxides, oxygen oxidation number -1/2. In case of ozonides, -1/3. In case of oxy fluoride, students, here it is showing +1 and +2. Clear? That means different oxidation states are showing. Okay, Namma. So this is nothing but this is about the exceptions of oxygen oxidation numbers, students. Oxygen oxidation numbers. Clear this one? Next, Nana, what is the next rule, students? Now see, Nana, next rule. This is a rule. Next rule is rule 5. Next rule. Next rule is rule 5. See here. Rule 5. So what is the rule 5, students? Yeah, I told you first A group, second A group, third A group, fourth A group, fifth A group. In those cases, how to find the oxidation numbers? Now see, students, first A group elements always showing the oxidation number is +1, students. You have to remember first A group elements always showing +1 oxidation state. First A group elements always showing +1, and second A group elements showing second A group elements oxidation number is +2, and coming to the third A group oxidation number is +3, Nana. From fourth A, okay na, so from fourth A to fourth A also we can take, Nana, +4, fourth A group also +4, but from fifth A to eighth A, okay, from fifth A to eighth A, what is the oxidation number, students? What is the oxidation numbers? Group number -8. What is the formula? Group number -8, Nana. Clear this one? So this is the formula, you have to use it. So from 5th A to 8th A is equal to group number -8. Now what is the 5th A group elements oxidation states, oxidation number, Nana? 5th A group elements, so group number is 5th A group. That means 5 minus 8, it is equal to -3. And coming to the 6th A group, oxidation number is equal to 6 minus 8 -2. And coming to the 7th A group oxidation number, 7th A group, that means group number is 7 minus 8, it is equal to -1. Next, 8th A group elements oxidation number is equal to 8 minus 8, 0. Clear students? Understanding Nana? So from 5th A to 8th A group, what is the formula students? Group number minus 8 amma. So 5th A group means oxidation number 5 minus 8, 6th A group oxidation number 6 minus 8, 7th A group 7 minus 8, 8th A group 8 minus 8. So these are the oxidation numbers minus 3, minus 2, minus 1, 0. Are you clear? First A group element is there always plus 1 only students. Second A group elements oxidation number plus 2, third A group plus 3, fourth A group plus 4. Are you clear? So this formula you have to remember students. Okay, from 5th A to 8th A, what is the formula? Group number minus 8 students. Understanding Nana? This is about the rule 5 students. Okay, now we are going to discuss rule 6 Nana. What is the rule 6? Now see students, in the case of compound ion, rule 6 Nana. Next one, rule 6. So in case of compound ions, in case of compound ions, for example, I am taking SO4 minus 2. Okay, now SO4 minus 2, it is a compound ion, correct? It is a compound ion students, correct? It is having the charge, it is a compound having the charge, compound ion, SO4 minus 2. Now in the case of compound ion, how to write the oxidation number? Here what is the charge is there? You have to take equal to the sum of the oxidation numbers of all the atoms present in the compound. So that means how to write here? SO4 minus 2 is there. I want to find sulfur oxidation state. Suppose sulfur oxidation state, I have to find it. Okay now, so that's how to find it. Sulfur 1 atom X I am taking, I am going to calculate, and 4 oxygens are there. 4 into oxygen oxidation number is minus 2 students, minus 2. What is the charge in a compound ion? Minus 2. Here how much charge is there? That charge you have to take equal to. If suppose charge is not there, you have to take equal to 0. If charge is there, you have to take equal to its charge. Clear this one? So like this you have to find it. So x minus 8 is equal to minus 2, x minus 2 plus 8, x is equal to plus 6. So this is the oxidation number of sulfur in the compound ion. Clear? Next coming to the rule 7 students. Now see Nana, rule 7. Okay, now see what is the rule 7 students. In the rule 7 I am discussing here H2 H2o8, H2 H2o8, H2so5. These compounds are oxo acids of sulfur students. Here this name is Marshall's acid. This name is Marshall's acid. This name is Caro's acid. Caro's acid students. It is also calling as peroxo monosulfuric acid. Sorry, disulfuric acid. Peroxo disulfuric acid. Okay, this name is peroxo monosulfuric acid. Nana, monosulfuric acid. Clear this one? Peroxo monosulfuric acid. Now here coming to the structure students, here peroxo, that means peroxy linkage is present in these two compounds. Now how to find the oxidation number of sulfur here? In those cases peroxy linkage. Now if you see the H2so5 structure, H2so5 peroxy linkage is present. What is the structure students? This is the H2so5, H2so5. This is H2so5 structure. This is the peroxy linkage. In peroxy linkage, oxygen oxidation number is how much Nana? Minus 1. Okay, now already I told you in case of peroxides, oxygen oxidation number how much I told you? Minus 1. Clear? So that's why here in case of peroxides, oxygen oxidation number minus 1, but the remaining oxygens are showing minus 2 oxidation state. Are you clear? So in this case 5 oxygens means 5 into minus 2 should not write, because there is a peroxy bond. That's why peroxy bond, in peroxy bond oxygens are showing minus 1 oxidation state, remaining oxygens are showing the minus 2. So how to find the sulfur oxidation number students in H2so5? H2so5. How to find the oxidation number of sulfur? 2 hydrogens are there. 2 into hydrogen oxidation number plus 1. Are you understanding? Oxidation number is plus 1. Sulfur I have to find it, X, and 5 oxygens are there. In 5 oxygens, 3 oxygens showing minus 2, remaining 2 oxygens showing minus 1. So 3 oxygens showing -2, remaining 2 oxygens showing total -1. Total 5 oxygens. 3 are 3 are showing -2, Nana. 1, 2, 3, -2 showing. Remaining 2 oxygen showing -1 equal to 0. Like this you have to find it. Now 2 plus x minus 6 minus 2, this one cancel. X is equal to +6 oxidation number. Are you clear? So in this peroxy linkage, this is the special case, students. Peroxy bond is there, oxidation number is different. Okay, Nama. Now I am going to discuss H2 H2o8. Now see, students, H2 H2o8. What is the structure of H2 H2o8? It is peroxo disulfuric acid. Na? So see here, students, H2 H2o8. S single bond O, yes, H2 H2o8. This is H2 H2o8, Nana. This one is peroxy linkage. This is the peroxy linkage. Single bond O, single bond O. Here oxidation number -1, -1. Here -2, -2. Here -2, -2, -2, -2. Correct? Now how to find the oxidation number? That means in total 8 oxygens, 6 oxygens are showing -2. Remaining 2 oxygens are showing -1. Understanding, Nana? So that is the oxidation number finding. So how to find it here? H2 H2o8, Nana. Total 2 hydrogens are there. So that's why 2 into hydrogen oxidation number is always +1. Plus 2 sulfurs are there. 2 into 8 sulfur we are going to find. 8 oxygens are there. In 8 oxygens, 6 oxygens are showing -2. Remaining 2 oxygens are showing -1. Then 2 plus 2x minus 12 minus 2. This one cancel. 2x minus 12 equal to 0. 2x is equal to +12. X is equal to +6. This is the oxidation number of sulfur in H2H2O8. Understanding, students? This is the special case in the case of peroxy linkage. Okay, Nama? Now we are going to discuss the rule 8. What is the rule 8? Clear? Now see, students, what is the rule 8? Rule 8, in organic compound, students, carbon can have any oxidation number from -4 to +4. Carbon is showing the oxidation number, students, from -4 to +4, students. It can show, okay, -4 to +4 oxidation number. For example, HCHO, I am taking the example HCHO. So in HCHO, what is the carbon oxidation number? Okay, now it is showing -4 to +4. Now I am going to calculate carbon oxidation number. 2 hydrogens are there. 2 into +1. Carbon I am going to calculate 1 oxygen. 1 into -2. Then 2 plus x minus 2. This 2 cancel. X is equal to 0. That means carbon oxidation number is 0, students. In the case of formaldehyde, HCHO. Clear this one. In the case of formaldehyde, oxidation number of carbon is 0, students. Clear this one. So these are the rules, students. By using these rules, Rana, you can easily calculate oxidation numbers of any atom, students, any element in the compound. And one more rule 9 also is there. Please, students, rule 9. What is the rule 9? Rule 9. In case of metal carbonyls, the oxidation number of metal carbonyl is always 0, students. For example, oxidation number of metal, okay, oxidation number of metal in metal carbonyl, it is 0, students. For example, I am taking NiCO4, nickel carbonyl, nickel tetracarbonyl. Now in this case, here carbonyl group, here oxidation number of metal in metal carbonyl is 0, because CO is a neutral compound, neutral ligand, students. So that's its oxidation number is 0. Then nickel also you will get 0, students. Any metal, students, here. Okay, now. So the oxidation number of, what is the oxidation number of nickel, students? Nickel is equal to 0. Oxidation number of metal, this is metal, this is the ligand. So oxidation number of nickel is equal to 0, students, because it is a neutral ligand. It is a neutral ligand. Neutral ligand means its charge is 0. Are you clear? It is not having any charge, so that's why its oxidation number is 0 student. It is a neutral ligand. Clear this one? So these are the rules students. Just once you practice this all the rules, you will get the idea. All the cases I discussed you students, what are the exceptions cases are there, what are exceptions are there, okay, in different cases, everything I discussed you, okay. After this topic students, after first you study this all the rules nana, then you try to calculate the oxidation numbers of elements students in the compounds, then you can easily calculate students, understanding nana. So I hope you like this video students. If you like this video, please like, share, comment and subscribe my channel students. Thank you very much students.